Then topic is okay. Topic is guys spanning tree protocol. Spanning tree protocol. What is the use of this protocol?
To avoid the loop trail, sir.
Yes, to avoid layer 2 loop. And you guys already know how loop can form in topology, right? See, suppose I have some computers, some sorry switches. Let's say switch 1, switch 2, and I have one more switch over here, that is switch 3. Let's say this is 0/0, this is 0/1, this is also 0/0, this is 0/1, this is 0/0, and this is 0/1. What will happen if someone will send one broadcast message to switch 1? One broadcast message, maybe ARP message or any other message, any broadcast message. Suppose one computer is connected over here whose IP address is, let's say, 10.1.1.1/24, right? Now this machine want to find the MAC address of their default gateway, right? Because suppose this machine want to send traffic to 8.8.8, so this machine have to resolve MAC address of their default gateway first, yes or no? So it will generate ARP, and you all know ARP is a broadcast message, and MAC address of this PC is, let's say, A. So what switch 1 will do? Switch 1 will make one entry in their MAC address table. On switch will receive frame on their interface 0/3. It will make one entry that I am receiving a frame from the device whose MAC address is A, and this device is connected on 0/1 port. After that, it is going to check the destination. So destination is broadcast. It will forward switch 2 also and switch 3 also, right? Again, switch 3 will do what? Switch 3 will also update their MAC address table. It will make one entry that I am learning as MAC A on which port? On 0/0 port. After that, it will check destination and it will forward to switch 2. Switch 2 will also make entry in their MAC address table. Switch 2 will receive first message, first frame from switch number 1. So it will learn source MAC address on which source MAC address on which interface? On interface 0/0. After some time, it will receive same frame on 0/1. So it is going to change the port ID. After again some time, it will receive same frame on 0/1. Again, it will change their entry. Again, it will receive same frame where on 0/1. So every time it is receiving a frame with same source MAC address on multiple port. Yes or no? So actually what switch is doing? Switch is flapping MAC address A between this port and this port. Yes or no? Actually switch 2 is flapping MAC address of A between these two switch port 0/0 and 0/1. In the same way, other switch is also doing same thing, right? This switch is also doing same thing. So this is nothing but loop, right? There are lots of traffic moving in my topology, right? So we need
Sir,
protocol. Yes.
अगर PC, if we configure IP address in PCA, in that scenario also it will generate
Yeah.
GR.
In that scenario also it will generate GR, gracious ARP,
Yeah.
to check the duplicate IP address, right?
And
I am saying
if
any broadcast message if switch will receive, doesn't matter it is an gracious ARP,
okay.
or message of let's say VTP,
DHCP packet.
VTP. Yes, any packet.
Yes, yes, sir.
Yes or no? Because
Yes, sir.
suppose switch is receiving any packet, let's say multicast at where destination is a multicast at layer 2. Then also switch 1 will do what? It will broadcast. Switch will treat multicast as well as broadcast message like same, like a broadcast. Yes or no?
Yes, sir.
Through VLAN, we can perform, multicast routing on a switch, but switch does not support multicasting. Switch treat multicast address as a broadcast. Done. So this is problem. Yes or no? Now we need to find the solution. So solution is STP. STP. Now guys, in STP we have some terminology. First of all, I must tell you, if you guys want to learn STP till advanced, right, everything about a spanning tree protocol like RSP, RPVST, PVST plus, MST, VTP version 3, these are really advanced things and part of CCIE. But I can cover everything in 6 to 7 days. But but what is requirement is, if you guys want to learn those things, then you have to understand basic very carefully. So really, if you want to discuss, STP as well, like BGP or OSPF, in OSPF we have discussed lots of things, types of network, area concept, right? Lots of topology. So like OSPF, if you want to learn everything about a spanning tree protocol also, please try to understand the basic things about a spanning tree protocol. Okay, and basic things is, first of all, we have some terminology in a spanning tree protocol. Let me make you familiar with those terminology first, and that terminology number one is root bridge. Root bridge. See, you are familiar with loop, that how loop can form topology. Now to avoid loop, what we are going to do, actually we are going to block the backup link. We will make one logical loop free topology. For that, in STP there are some selection. In STP, like OSPF, guys, tell me what is the use of DR in OSPF? DR is reduce the LSS flooding, number of adjacencies. It is used to reduce number of adjacencies, or LSA flooding, you can say. Yes or no? So
Yes, sir.
in a single broadcast domain, we select one router as a monitor router, right, who will control the topology. Like that, in a spanning tree protocol also, we are going to elect one switch as a main switch, and that will be your root bridge. Okay, you will learn lots of things about root bridge, don't worry. Second terminology is BPDU. Third terminology is cost. Cost to reach root bridge, or you can say cost path to reach root bridge, CPR. Okay, let me say cost only over here. There are two types of cost, we will understand, don't worry. Fourth thing is root port, and fifth one is designated port. These terminology are very important, guys, in basic. Done. Now question is, what is root bridge? So a switch which has the best bridge ID, that switch will become what? Root bridge. See, suppose I have one topology over here, switch 1, switch 2, and switch 3. Guys, in this topology, tell me, loop can form or not? First of all,
Yes, sir.
Yes, sir. Loop is
Yes, sir.
formed.
switch 2 and switch 3. Yes, definitely loop will form, and if you want to avoid loop, what you can do? You can disconnect one cable, maybe this cable, or you can disconnect this cable. Yes or no? Actually, you will remove the alternate path, backup path. So suppose if you will remove this link from here, then tell me, can loop form there? If you will
No,
remove
sir.
this cable, or if you will run shutdown command on this interface, then loop will not form, because now your logical topology is loop free. Now your logical topology is like this. Okay. So actually we are trying to design one logical topology from this physical topology, and that should be loop free. For that, we are going to select one switch as a root bridge first. Now question is, which switch will become root bridge? So switch which will have the lower bridge ID. Now question is, what is bridge ID? What is bridge ID? So guys, bridge ID is combination of two things. Bridge ID is combination of two things. Can anyone tell me the name of those two things?
Sir, one is
Priority.
priority.
Okay.
One more is MAC address.
Base MAC address. Very good. Base
MAC
MAC
address.
address. Suppose MAC address of switch A is 0A, MAC address of switch B is, let's say, 0B, and MAC address of switch C is, let's say, 0C. By default, priority on every switches is same, and that is 32768. Right? So what will be the breeze ID of switch 1, guys? What will be the breeze ID of switch 1?
So same only 32768.
32768 plus 0A, because it is combination of these two things. Priority plus base MAC address, yes or no? So this will be the
Sir,
breeze ID of switch 1. What will be the breeze ID of switch 2? 32768 plus 0B. 32768 is by default priority plus base MAC address. This is my root breeze ID. After that, this switch will also have one root breeze ID. That will be, sorry, breeze ID. That will be 32768 plus 0C. Now tell me, which switch will become root breeze first of all?
sir, 0A.
0A?
Yes.
Why this switch will become root breeze? Because this
Because
switch have lower breeze ID. Done, guys? Because this switch have lower breeze ID. All other switch have lower breeze ID. That's why switch 1 have become what? Root bridge. Done. After that, second terminology is BPTU. So BPTU is nothing but like your hello message. What is the use of hello message in OSPF?
To establish neighborship and to see
Keep alive message.
Yeah, there are lots of other messages as well to share the information, right? Actually, all messages are used to share information with neighbor. Yes or no? Hello message also, update message also, and DVD message also. All messages are used to share some information with neighbor. Like in STP, we have only one type of message, that is BPDU. And this message is divided into two parts. One is configuration BPDU. Configuration BPDU. And second one is TCN BPDU. So there are two types of message in spanning tree protocol. First one is BPDU and second one is TCN BPDU. First one is, sorry, configuration BPDU and second one is TCN BPDU. TCN stands for topology change notification. This is not much important, but very important to understand the impact on network whenever topology will change. Whenever change will occur in the topology, then what impact will occur in the network? For that, TCN BPDU is important. But configuration BPDU is very important. Configuration BPDU is very important. BPDU stands for what, guys? Can anyone tell me the full form of BPDU?
Sir, bridge protocol data unit.
Protocol data unit. Bridge protocol
data unit.
Data unit. नाम पे नहीं जाना है, right? You don't need to do anything with name. Okay, so configuration BPDU. First of all, BPDU. So root bridge always generate a hello message after every 2 seconds, and that hello message is called configuration BPDU. That is called configuration BPDU. That means which switch will generate configuration BPDU?
Root bridge.
Root bridge switch will only generate configuration BPDU after every 2 seconds.
2 seconds.
At the initial time when you will connect these three switches together, right? Every switches will think that I am a root bridge, yes or no? Because suppose bridge ID of this switch is 32768 plus 0A. Bridge ID of this switch is, let's say, 32768 plus 0B, and switch 3, suppose 32768 plus 0C. Now switch 3 don't know what is the bridge ID of switch 1. So this switch will also think that what? I am root bridge. At the initial time, all routers thinks that I am DR, but it will wait for 30 seconds. If within 30 seconds no one is going to send me the hello message with higher router ID, then I will declare myself as DR. Yes or no? This is concept. This is DR and BDR election.
It waits for 40 seconds.
Yes, it waits for 40 seconds. Right? Like that, every switch is thinking what? I am root bridge, I am root bridge. So whenever a switch will come up, it will send configuration BPDU. What configuration BPDU? In the same way, switch 1 will also send the configuration BPDU, because both are thinking what? I am root bridge. But on switch 2 will receive the BPDU of switch 1. It will stop advertising configuration BPDU. Done. Once a switch will came to know that I am not root bridge, I will stop the advertising what? Configuration BPDU. A switch will advertise, will send configuration BPDU until and unless they are thinking that I am root bridge. Done. After that, it will never generate. Okay. So actually first use of configuration BPDU is to elect root bridge. Yes or no? Because through configuration BPDU we can elect root bridge. Every time every switches will send configuration BPDU to each other. Then all switch will come to know that about which switch have lower bridge ID, and that switch will become root bridge automatically. Right or wrong? So actually configuration BPDU is used to elect root bridge. Yes or no?
Yes, sir.
Yes,
Always
sir.
keep in mind BPDU message carry this information, bridge ID of a switch. In every BPDU there will be information about bridge ID. So only root bridge after that, on selection will happen, after that only root bridge switch will generate configuration BPDU after every 2 seconds. Now let me discuss some contents of BPDU first. Content of BPDUs. Okay, so inside BPDU there will be information about protocol ID, protocol ID will be there. After that version will be there, and what information else will be there, guys? Type.
Flags.
That it is an type field. Through type
BPDU.
we can define, we can identify that it is an configuration BPDU or TCN BPDU. For that there will be one type field as well. Okay, then flag, then
bridge ID.
bridge ID only.
Yes.
Or root bridge ID. Yes, root bridge ID. There will be information about root bridge ID and
path host.
Root bridge ID. After that
path cost.
Then
sender or forwarder bridge ID.
Sender, or you can say designated bridge ID. Say sender. Yes. It is more clear. Sender bridge ID. Then
Sender port ID.
sender port ID.
Yeah.
Really, sender port ID will be there inside the BPDU, guys. Will this information carry by BPDU?
Yes, sir.
Okay. Then there will be forward
Message
message time. Message time will be, it will be what?
2 seconds.
Message time 20 seconds.
20 seconds.
Okay, then
Messages age.
message age बिल्कुल. Then
Forward delay time.
forward delay time, very good. Then
Hello time. Hello timer.
hello interval time. Hello time. That will be 2 seconds.
2 seconds.
Done. These are the content of BPDU. Okay, guys. Whenever root bridge will generate a BPDU, always keep in mind root bridge generate cost 0 BPDU, because this is path cost to reach root bridge. This is not cost of port. This is path cost to reach root bridge. So distance to reach root bridge from root bridge will be always what? 0. Okay. So this is also an important point here. You should keep in mind that root bridge always generate cost 0 BPDU, and cost of receiving interface will be added. Done. Now understand STP ports. Then again I will come on BPDU. STP ports ID. Port ID. What is STP port ID, guys? Again, STP port ID is combination of two things. STP port ID is combination of two things. First one is again priority, and second one is interface ID. Okay. By default priority is what?
128.
128. By default priority is 128 of a port. And interface ID is, as you know, 0/0, 0/1, this thing. Done. Let's say on port number 1, STP port ID will become what? 128.1. It will be port ID of a interface whose interface ID is 1. Like this. Clear? Clear, guys?
Yes, sir.
Now suppose I have some switch over here. This is my switch 1, switch 2, and switch 3. Done. Suppose this is 0/0, this is 0/1, this is 0/0, and this is also 0/0. Right? So cost of this link will be what? Cost of this port is by default 128. And cost of this link is what? Cost of this link is
19.
19 for fast Ethernet. And
Fast
STP never reveal the formula to calculate cost of a link. On a fast Ethernet link, cost is 19. On a Ethernet link, can anyone tell me cost?
100.
100. Very good, right? That means definitely cost is inversely proportional to bandwidth. Because if bandwidth is high, that means we are getting least cost. If bandwidth is low, so cost is higher. But there is no any formula to calculate cost. You know, in lots of books I have tried to find the formula to calculate the cost of a link in STP, but I didn't get it. After that, I decided that STP never revealed the formula to find the what is the formula to calculate the cost. No one can teach you this, right? So always keep in mind cost on a fast Ethernet link will be 19 over here also, 19 over here also, 19, 19. These are the cost. So what will happen? Suppose MAC address of this switch is 0A, MAC address of this switch is 0B, MAC address of this switch is 0C. So what will happen once you will enable STP? Actually STP is by default running. What will happen? Suppose I am connecting these three switch first time. So switch 1 will generate what? One configuration BPDU. In the configuration BPDU, what will be the information? In the configuration BPDU, there will be root bridge ID. This is important field of content of BPDU. All important part I am going to discuss here. There will be information about root bridge ID. So what will be the root bridge ID? 32768 plus 0A. After that, there will be information about cost. Cost will be what? 0. As I told you that cost to reach root bridge from root bridge will be always 0. After that, there will be information about sender bridge ID. Sender bridge ID will be what? Same 32768 plus 0A. Yes or no? After that, there will be information about sender port ID. Sender port ID. So tell me what will be the sender port ID?
0/0.
0/0.
128.0.
Yes, sir. Yes, sir.
128.0. Yes or no?
Yes, sir.
This
Yes.
will be the BPDU of switch 1. And these are the important information. Done, guys? These are the important information of BPDU. After that, switch 1 will forward it to switch 2. What switch 2 will do? Switch 2 will do what? Switch 2 will change the sender bridge ID only. Because first of all, switch 2 will came to know that switch 1 is what? Root bridge. So now my root bridge ID is 327 32768 plus 0A. After that, cost. What will be the cost over here, guys?
19.
19. Cost will be always added on the receiving interface. So switch 2 is receiving this BPDU on this port. So it will add cost of this port over here. It will become what? 90. After that, sender bridge ID. So sender bridge ID will be what?
32768 plus 0A.
32768 plus 0B. 0B or 0A? 0B. B. Because now switch 2 is sending this to switch 3. So sender will be
Okay.
switch 2. Root bridge ID is here. Root bridge ID will be the bridge ID of switch 1. But my designated bridge ID will be 32768 plus 0B. My bridge ID. After that, sender port ID. Sender port ID. And it will be what? 128.0. Yes or no? Then it will forward it to switch 3. Here guys, tell me root bridge ID will be same. 32768 plus 0A. Cost will be what?
38, sir.
38, right? Because cost 19 is coming in the update, and cost of my receiving interface is also 19. So 19 plus 19, cost will be 38. That means this is the cost to reach root bridge. This is the distance to reach root bridge from switch number 3. This is the distance from switch 2 to reach root bridge. After that, suppose this switch is also sending BPDU to other switch. So sender bridge ID will be what? Sender bridge ID?
0C.
Yes. Plus 0C, and designated port ID will be the port ID of exit interface. Done. Guys, is it clear? Till here, if anyone have any doubt, you can ask. Otherwise, now I am going to start the actual things of spanning tree protocol. But before it, if anyone have any issue, then let me know. Clear, Giri?
Yes, sir.
Okay, then let's move. Okay. Now we have to understand how to identify the superior BPDU, the best BPDU, because suppose a switch is receiving BPDU from multiple switches. Like in my scenario, switch 2 is receiving BPDU to switch 1 also, and is receiving BPDU of switch 3 also. This is switch 2, here is switch 1, here is switch 3. Like switch 1 was generating BPDU, in the same way switch 3 is also generating BPDU. So actually switch 2 is receiving BPDU from switch 1 also and from switch 2 also. So this switch is going to find the superior BPDU, means the best BPDU. I am receiving best BPDU on which port? From switch number 1 or from switch number 2. And this is the concern of STP. Everything is here only. How switch is going to identify the superior BPDU? Okay. Okay, guys. So suppose I have one switch over here. Let's say this is my switch, and this switch is receiving BPDU from one switch on this port, on let's say 0/0 port, and one BPDU on 0/1 port, right? So in the BPDU, first information is root bridge ID. So suppose here root bridge ID is when switch 1 is sending the BPDU to switch 2, then root bridge ID will be 32768 plus 0A. And when switch 3 will send BPDU, bridge ID will be 32768 plus 0C. So this is the first way. Through root bridge ID, it can identify I am receiving superior BPDU over here, because here I am receiving the BPDU with lower bridge ID, lower root bridge ID. So to identify the superior BPDU, switches is going to check first information, that is root bridge ID. So from where switch is receiving lower root bridge ID BPDU, that will become what? Best. Is it clear? Is it clear, guys?
Yes, sir.
Yes.
Yes,
Now
sir.
question is, suppose here also root bridge ID is 32768, and here also root bridge ID is 32768 plus 0A. This time root bridge is same. Yes or no? This time root bridge is same. Then it is going to check what?
Path cost.
It is going to check path cost. Path cost. So cost to reach the root bridge. Suppose here cost is 19 and here cost is 38. So again, which path will become superior? This path. This is superior BPDU, right? So lower cost is always preferred, okay, to identify the superior BPDU. So here on the basis of path cost also we can identify superior BPDU. If I am receiving BPDU from the same route bridge but from two sides, then I will check the path cost. If path cost is also same, then it is going to check what?
Center
If,
bridge ID.
yes, sender bridge ID. And sender bridge ID over here is 32768 plus 0 A, and let's say sender bridge ID over here is 32768 plus 0 D. So which BPDU is superior? Switch which is
0 by
receiving on
0.
0/0 or on 0/1? On 0/0. Yes or no? And can anyone tell me, can this be same in the BPDU? Can sender bridge ID will be same into BPDU or not? Can be same or not?
Yes, sir. It can be so.
Yes, it can be same. In which type of scenario?
Sir, when we connect two switches with redundant link, then that time.
Yes, whenever we will connect two link with more than one, two switch with more than two link. Right? Let's say I have one switch over here and one switch over here. Suppose the MAC address of this switch is 0A, MAC address of this switch is 0B. I am connecting how many link over here? Two link. Let's say this is my 0/0, this is my 0/1, this is my 0/0, this is my 0/1, or I can say this is my 0/1 or this is my 0/0, right? Now what will be the bridge ID of switch 1? 32768 plus 0A. Bridge ID of switch 2 will be 32768 plus 0B. Both switches going to advertise configuration BPDU. So switch 2 will receive configuration BPDU over here also and over here also. What will be the root bridge ID over here, guys? 32768 plus 0A. This is the root bridge ID. Here also root bridge ID will be 32768 plus 0A. Then it is going to check what? Cost. So cost over here will be what? 19, and cost over here will be also what? 19. Then it is going to check what? Sender bridge ID. So sender bridge ID over here will be 32768 plus 0A. Sender bridge ID over here is 32768 plus 0A. Yes or no? Now sender
Yes,
bridge
sir.
ID is also same in this scenario. Then switch is going to check what?
Sender port ID.
Sender port ID. Port ID. So sender port ID over here will be what? What will be the sender port ID over here?
128.0.
128.0. Over here?
Dot 1.
128.1. So lower or higher, which one is preferred?
Lower.
Lower. That means switch 2 is receiving superior BPDU on this port. Yes or no? Or my scenario can be different as well. Let's say I have a scenario like this. I have one switch over here. This switch is connected with one hub, and through hub I have two link, and like this I have connected one another switch. This is my switch 1, this is my switch 2. Here MAC address is let's say 0A, here MAC address is let's say 0B. Right? Now switch 1 will send BPDU where root bridge ID will be 32768 plus 0A. Right? Cost will be 0. Cost will be 0. Then
68 plus 0.
3 32768 plus 0A is the sender ID. Then after that, what information will be there?
Port ID,
Port,
center port ID.
port ID. So suppose this is 0/0, this is 0/1, this is 0/0, this is 0/0, and this one is 0/1. Right? Now sender port ID will be, let's say, 128.0. This is BPDU of switch 1. Right? Same BPDU will receive by hub, and hub will forward it from here also, and it will forward it from here also. Yes or no? Again, this switch is receiving BPDU on two port. Right? Now tell me, in this scenario, sender port ID is also same. What switch is going to check? Then switch is going to check receiving port ID. And receiving port ID of this interface is lower. So this interface will become what? On this interface, switch is receiving what? Superior BPDU. Done, guys?
Port ID.
Yes? Port ID will be same, na? Port ID will be what? 19 over here, 19 over here. Sorry,
Center
cost
port
will
ID.
be, port ID will be 128.0 over here also,
Yes, sir.
over here also. Then it is going to check what? Receiving port ID.
Yes, sir.
And I am not talking about the port ID 0/0. I am talking about the STP port ID. Here STP port ID will be 128.0. Here STP port ID will be 128.1. Right? I am talking about this port ID. Okay, guys. Is it clear?
If sender port ID is same, then it will check receiving port ID, sir.
If sender port ID is same, then it will check receiving port ID. Yes.
Okay.
Okay. So series is, if I will talk about the series, so what is series? First thing
Sir,
is, yeah, bolo bolo.
Sir, in real time scenario, it's not possible, no, sir?
What? No, 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 it is not possible. Just to make you understand the concept.
Okay.
First of all, it will going to check root bridge ID. Then it is going to check cost. Root
path
path
cost.
cost.
Path cost, sir.
RPC. Third,
Sender bridge ID.
sender bridge ID. Fourth,
Sender port ID.
very good, sender port ID. Fifth,
Receiver port.
Receiving port ID.
these are the election criteria of superior BPDU. Done, guys? Now just give me 1 second. So hope till here MAC address over here is, let's say, 0A. MAC address of switch 2 is, let's say, 0B. MAC address of switch 3 is 0C, and MAC address of switch 4 is, let's say, 0D. Done. This is, guys, let's say 19/19 by 19 and 20, port number 90 and 20, port number, let's say 21 and 22. These two are also 19 and 20. This is, let's say, 21 and 22. Done. This is, let's say, 23, and this one is 24. This one is also 23. This one is also 24. Done. Okay, first of all, breeze ID of switch 1 will be 32768 plus 0A. Breeze ID of switch 2 is 32768 plus 0B. Three two seven six eight plus 0C D, and here 32768 plus 0C. Done. Now, first of all, tell me which switch will become root breeze. So,
Which one?
Which one, sir?
root breeze. Very good. Now, all ports of this switch will become what?
Designated port.
Designated port.
Designated
STR
port. So,
port.
this port will become DP. This is DP. This one is also DP. This one is also DP. And this is also DP. This is also DP. And this one is also DP. On switch number 2, which port will become RP?
19.
19.
This port will become RP. Very good. Because of lower sender port ID.
Sender port ID.
Yes, sir. And
Yes.
switch 3, 21.
This one,
Yes,
RP. Because of lower sender port ID. On switch 4,
23.
23,
23.
RP. Very good. Now, which port will become DP on switch 2? DP,
21.
port number 21.
Mm.
Now, on each segment, you need to find the DP.
21 and 23, sir.
How you are calculating?
No.
How you are calculating, brother? First of all, tell me that also. Actually, RP election is done. Now
Yes.
we need to find DP on each segment.
Mm-hmm.
So just you need to check two things. Just you need to check two things. First one is, let's say I am checking on this link. So here I am sending BPDU, and this switch is also sending BPDU, which is sending superior BPDU.
Switch.
That's it.
Okay.
Like that you can find the DP na.
Switch 2 to switch 4,
Okay, sir.
21.
On switch number 2, how many DP are there? Okay, let me discuss one by one. See, on this switch, in this port, it is receiving superior BPDU or transmitting superior BPDU to this. It is receiving.
Sir.
Or the second way is, I am also sending BPDU and this port is also sending BPDU. Which one is sending superior BPDU? My neighbor. That means I am not
Which one,
DP.
sir?
Yes, that means this port is not DP. This is also
Yes,
a
sir.
way. Okay. On this link, so there is no DP. On this link, see, I'm sending BPDU
Switch
This is
to
a
and this switch is also sending
Yes.
BPDU. In both BPDU, root bridge ID will be what?
Same, 0A.
0B and 0C.
No, root
0B?
bridge ID is 0A.
Root
Sender,
bridge ID will be same.
Zero,
sender
yeah.
bridge ID is 0B and 0C.
Center bridge
Cost
ID
will
is
be
0B.
also same. Cost will be also same. Yes or
Yeah.
no?
Yes,
Center bridge ID would be different.
Sender bridge ID. So sender bridge of ID of
0B.
switch B is lower. That means
Yes.
both port of these two ports will become what? DP.
DP.
Yes or
DP port.
no? Okay. So this two port is DP DP. DP. Now let's talk about 23 and sorry 21 and 22.
Switch 2 will become DP.
This port on this port, this will become DP.
Mm.
Yes.
This will also become DP.
Yes.
DP and DP.
Between switch 3 and switch 4 also we have to find, right?
Between, yes, definitely. Now let's talk about switch 3. So tell me, port
19.
20.
Switch 3 will become DP 1920.
Which port will become DP?
Switch 3.
1920.
First of all, tell me this port will become DP or not?
Switch 4?
Which one, sir?
No.
This port.
No, sir.
No,
Sir, that is
Because I
alternate,
am not
sir.
sending superior BPU. My actually, or you can say DP is already there.
Yes.
Yes, sir.
So this is also, and my neighbor is
Alternate.
transmitting superior BPDU on this link.
Swi-
Okay.
Port number
This
22
port
will become
No,
alternate
already DP available.
on the link already DP available.
Yes.
This
RP.
port already DP available. So these two port will become what? Alternate and alternate. Because RP can, because RP is already there.
Yeah.
So this port will become what? Alternate. Right? In the same way, this port will become also what? Alternate. Right?
And 1920
1920 is
9020.
DP.
AP port, sir.
This is DP
Yeah.
because of lower sender ID.
Sender ID.
This one is also DP. This
The
one
cost
is
is also less, right? Switch 1,
yes.
switch 3, 1, 2, 3 हो जाएगा ना ये पूरा घूम के आएगा.
Okay, cost will also higher. So from here cost will be what?
This will be same.
Same na? Cost is same. Okay, and this port will also become what? Alternate. Right? This port will also become what? Alternate. And this port will also become what? Alternate. Right? This port will also become what? Alternate.
Alternate.
So guys, logical topology is switch 1, switch 2, switch 3 and switch 4. Tell me the logical topology.
19.
How many?
19.
And this port is also alternate, this port. Na? Yes. Yeah. Link is there between switch 1 and switch 2?
Yes.
How many link? One link.
Via 19.
Is link there between switch 1 and switch 3? Yes. How many link? One
1
link.
via 21.
This is your alternate. Right? Is link there between switch 2 and 4? No.
Is 2 and 4?
Yes.
No, no,
No, sir.
No any link is there.
no.
No.
Which
Yes or
one and
no?
4?
Switch
R2,
2 and switch
R2
4.
R4 is switch. Sorry, switch to
Is there any
switch
link
4,
between
no.
switch 1 and switch 4?
Yes.
This is 1. This is 2.
Switch 4.
Yes, via
This
23.
is, yes, very good. 4. So there is one link between switch 1 and switch 4. Is there any more link?
No.
No.
So this is loop free topology. Yes or no? Now can any other topology can be formed that is loop free from this physical topology. Yes. Suppose on switch number 2, if I will set priority what? Let's say here I am setting priority 0. Priority over here is 0. Then this switch will become root bridge. Yes or no? So all port of this switch will become what? DP. So now I am going to give you some task over here. My requirement is I am connecting one computer here and one computer over here. IP address of this machine is 10.1.1.1. IP address of this machine is 10.1.1.2. Done. Any MAC address you can assume. So now if I will ping 10.1.1.2 from 10.1.1.1, which path will use? It is going to use which path?
1 to 4.
This path?
Yeah.
Yes.
Yes or no?
Yes.
But what I want, first task is, I want that whenever 10.1.1.1 want to ping 10.1.2, my traffic should go like this. Can you achieve it, guys?
Yes, by reducing the priority, sir.
Yeah, priority, cost. You have lots
Yes.
of options.
Yes, sir.
So by using those things, can you achieve it?
Yes.
So this
Yes,
is
sir.
first task. First task is whenever, again I am speaking, first task is whenever PC1 ping to PC2, 10.1 ping to 10.2, traffic should go via switch 1 to switch 3 and then switch 3 to switch 4. Okay. First. Second requirement is whenever 10.1 ping to 10.2, it should go like this. Via switch 1 to switch 2 and then switch 2 to switch 4. Only these two path manipulation you guys need to perform by yourself. Very easy, or anyone can do. Just you need command to change the priority, to configure the priority, to change the uh, route path cost, to change the port priority. So you need only command, yes or no? But don't worry about the command, just show me your logical free topology. Suppose here you can write down that I am using priority 0 over here, or here I am using MAC address, sorry, I'm saying MAC address, port ID 20 instead of 19. So anything you can configure, you can manipulate path by using two things, priority plus priority of root bridge and priority of port.
Sir,
Then
we
yes,
can use two different VLAN.
two different, not single VLAN. In single
Only
VLAN I am
single.
telling you.
If we
Yeah.
configure the priority 0, then it will 0 switch 2 will become root bridge.
Yes, here if you will set priority 0,
Yeah.
then what will happen? This switch will become root bridge.
Yes, sir.
All port will become DP, D, 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 D. Right? This port will become what? RP. On this switch, which port will become RP? This port. On this switch, which port will become RP? This port. Yes or no? So your logical
Yes,
topology is switch 1, switch 2, switch 3 and switch 4. What is your logical topology? Have you achieved your task? Yes, you have achieved your second task.
yes, sir.
What about your first task?
C को कर देंगे ना रूट प्रायोरिटी.
Here you will set priority 0.
Then
what will happen? Let me check. What will be the logical topology?
Sir, I have one question.
Wait, brother. Wait, let me set priority 0 over here. So DP, 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 DP. RP,
21, 23,
RP,
19.
here between switch 2 and 4.
So
But
3
sir,
and
at the same time, it's not
RP.
possible, no, sir.
On this switch, which port is RP? This port, RP. So your logical topology is this. Yes, now you can, do you think you have achieved the, and there is one link over
One
here.
second.
So here is your PC. Yes, okay. You can achieve this task by changing the priority on switch 2 also. But suppose now what I want, that you are not allowed to change, root bridge priority. Then what you can do? In first task, let's say you are not allowed to change root bridge priority. Root bridge priority should be same on link. Then you have to manipulate with
Cost.
path cost. Yes or no? So let's say for first task you are allowed to change priority, and for second task you are not allowed to change root bridge priority. Then for second task you are not allowed to change root bridge priority. Now we have some states in in spanning tree protocol. Can anyone tell me about those states? States of STP. Number 1, disable. Number 2, blocking. Guys, why we have multiple states? Everything you will understand in upcoming time. Don't worry. Then we have listening. Then we have learning. And then we have forwarding. A disable port means your port is shut down. Your port is, let's say your port is administratively down. So STP states will be disabled on that port. If your port is no shutdown, that means STP is enabled and states will never be disabled, right? In second scenario, then state can be disabled is because of error disable. Also, state can be disabled, so we will understand. But that are different, not in STP disable. I'm talking about the disable state of STP, spanning tree protocol. So understand that this port is administratively down, and whenever a port is disabled, switch is not going to send any BPDU from that port, and switch is not going to receive any BPDU from that port also, right? ना तो BPDU सेंड करेगा डाउन इंटरफेस से और ना ही BPDU रिसीव करेगा. ओके, so not send, not receive. BPDU will be not sended from the disabled port, and BPDU will be not received on the disabled port. Then blocking port. From blocking port we cannot send BPDU. We cannot send BPDU, but we can receive BPDU over here. On blocking port, blocking state means port which will become what? Alternate. That state of that port will be blocking. So on blocking port also they are receiving BPDU. Just now not only transmitting the BPDU from there, because only DP port transmit BPDU. RP port is also not going to transmit any BPDU. Only DP port will transmit BPDU. So from blocking port we can receive the BPDU, but we cannot send the BPDU. And in listening states we can send the BPDU as well as we can receive the BPDU. Here also in learning state we can send the BPDU or we can receive the BPDU, and in forwarding state also we can send BPDU, we can receive BPDU. Let me discuss about the MAC address learning, because this is the function of switch. Switch always and learn source MAC address, but on the disabled port switch is not going to learn any MAC address. On the blocking interface also switch is not going to learn any MAC address. On the listening state also switch is not going to learn any MAC address, but on the learning state switch can start learning MAC address, or in forwarding states also it can learn MAC address. Let's discuss about the data flow. So disable state cannot forward data, blocking state cannot forward data, listening state cannot forward data, learning state cannot forward data, and forwarding state can only forward data. Done. So data forwarding will happen only in forwarding state. MAC address learning will be started in learning state, and BPDU sending will start from listening state. Done. Is it clear, guys? So whenever a switch will come up, first of all switch will go in which state? In disable state. After that they will go in blocking state. So suppose a port which role is what? Alternate. That port will stuck in this state. Only those port will move from blocking to listening whose role is not alternate, whose role is designated or DP or RP. Only DP and RP port will move from blocking to listening state. Done. Alternate port will stuck in the blocking state. This is the concept of spanning tree protocol states. Is it clear?
Yes, sir.
Everyone, guys, any question?
Yes, sir.